Hi, Math 2 students. So far, we've been doing a lot of work with the vertex form of a quadratic. So to refresh your memory, the vertex form of a quadratic is going to be in the form y equals a times x minus h squared plus k, where we know that the vertex is h comma k. Or in other words, you switch the sign of this guy, keep the sign of this guy for your vertex, okay? Now, we are going to be learning about something called standard form, okay? And standard form of a quadratic is going to be ax squared plus bx plus c. Now, we actually have seen these already. Last unit, we were working on factoring things that look like this. So, like, for example, if we look at example A, right, we have practiced factoring things like this. Now, we're going to work on kind of using this form of a quadratic to identify different features. So, to find so first off, the c value, that's the constant on the end. That's the guy that doesn't have a variable or an x attached to it. It's just a number. That is going to give you the y-intercept, okay? So, for example, if we're talking about the y-intercept, if we look, the c value on example A is -5. So our y-intercept here would be 0, -5. So that is one of the biggest things that standard form is good for, is it directly gives you the y-intercept of your graph. Now, while the vertex isn't kind of like in your face like it is in vertex form, you can still find it quite easily. To find the axis of symmetry, you are going to do -b all over 2a. So what does that mean? That means that you are going to take the value, in front of your x, switch the sign of it, so that's what -b is, and then divide it by 2 times the value in front of your x squared. So what's going on here? Well, let's first identify a and b. Okay, for example A, we can see that our a value is 2 and our b value is 8. And obviously, we already identified our c value is -5. So if we are using this -b divided by 2a to find the, and I guess I should say x equals, right? Because axis of symmetry is a line. So to find the axis of symmetry, all right, we're going to do opposite of b, because that's -b, all over 2 times your a value, which is 2. So again, I took my a value of 2 and put that in here. And I took my b value of 8 and put it in there. All right, so when I simplify this, I get -8 over 4, which is -2. So my axis of symmetry is going to be x equals -2. Okay, now additionally, if you guys recall, the axis of symmetry is equal to the x value of your vertex. So the x value of your vertex is also -b all over 2a. All right. So since we found our axis of symmetry to be -2, we know that our vertex is going to be -2 comma something. Okay. We don't know what the y value is, but fortunately, we've been practicing plugging into quadratics. So what we're going to do is take the x value of our vertex and plug it into the function to get the y value out. So we end up doing 2 times -2 squared plus 8 times -2 minus 5. Now you could just go straight to your calculator to plug this in. And we end up with 2 times -2 squared plus 8 times -2, that is a 5. And minus 5. All right, so when I do this, I get a -13. So these are the coordinates of my vertex. All right, so kind of to reiterate, to find the y-intercept from standard form, we know that it's just the c value. And to find the vertex, it's a little bit more involved. We have to do the -b over 2a. Okay, so let's take a look at number 2 here. We can see that this guy is in vertex form. Okay, do you see how it fits this form that we've worked with previously, where it's the y equals a times x minus h squared plus k? Okay, so this is in vertex form. So fortunately, finding the vertex is actually pretty easy. All right, what would be the vertex of the sky? The vertex of the sky is -8, -5. All right. Now, finding the y-intercept, it's not as in your face as standard form, but we can easily find the y-intercept. We know that y-intercepts always have an x value of 0. So what you're going to go do is plug in an x value of 0 into this guy. All right, so we're going to do 2 times 0 plus 8 squared minus 5. So again, you can just go to your calculator and plug that in. 2, 0 plus 8, close parentheses, squared minus 5. And I got, that seems dramatic, but I think that appears to be right. So we end up with 0, 123. All right, so this guy would be my y-intercept. All right, so again, to find the y-intercept, and really you could have plugged in 0 to find the y-intercept of this guy here, because if you do 2 times 0 squared plus 8 times 0 minus 5, if you plug that into your calculator, you also get a -5 out, but you don't even have to do all that work because it's just a constant on the end there. With vertex form, you do actually have to go in and plug in 0 for x to find the y-intercept. All right. Alrighty, so let's go ahead and take a look here at example B. What form is this in? Is this guy in vertex form or is he in standard form? So this guy is in standard form. If you recall, that is the ax squared plus bx plus c. All right. So first off, they ask us for the axis of symmetry. So if we look back in our notes, to find the axis of symmetry, we have to do x equals -b all over 2a. So first, let's identify what a, b, and c are for this quadratic. My a value is 2, my b value is 4, and my c value is 3. So if I'm trying to do -b all over 2 times a, I am going to do -4 all over 2 times 2. And I end up with -4 over 4, which gives me an axis of symmetry of -1. All right, so that is the first piece of information we got here. The next thing they want us to find is the vertex. Now, we've already found part of our vertex. If you recall, the axis of symmetry gives you the x value of your vertex. To find the y value, we need to go and plug a -1 into this function. So we're going to do 2 times -1 squared plus 4 times -1 plus 3. So when you plug that into your calculator, what do you get out? So we can go ahead, plug it in here, and we get 2 -1 squared plus 4 -1 plus 3. And I get a 1 out, okay? So the y value of my vertex is 1. So my vertex is -1, 1. All right? And then to find my y-intercept. Now keep in mind, no matter what function you have to find your y-intercept, you know that you can always just plug 0 in for x. No matter what form it's in, that is one way to find your y-intercept. However, because this is in standard form, we don't got to do that much work, okay? When we are in standard form, we know that our y-intercept is going to be 0, comma, our c value, which is 3. All right. Now, they do want us to graph this, okay? So we did talk about how we graph, and it's the same that we do for vertex form. We're again going to make our little chart, and we want our 5 points here, okay? And make sure you put your vertex again smack dab in the middle there. Now, we want to plug in two values before -1, so we're going to plug in a -2 and a -3, and then two values after, which would be 0 and 1. Okay, so again, this is our function. We've got 2x squared plus 4x plus 3. So I'm going to go ahead and plug a -3 into the function. So I'm going to do 2 -3 squared plus 4 times -3 plus 3. And I get a 9 out. All right. Now go ahead and plug a -2 into the function. See what you get out. So when I plug a -2 into the function, I get a 3 out. All right. And if you recall, you can just kind of reflect these. Okay. And one thing I want to point out is it makes sense that when we plug a 0 in, we get a 3 out, because guess what? That was our y-intercept. So we can go ahead and graph these. Unfortunately, a lot of these points are going to be off, so we really can only plot 3 points on this tiny graph here. So we've got -1, 1, and we've got 0, 3, and we've got -2, 3. Now, obviously, -3, 9, that's going to be off the chart here. So if we have like 6, 7, 8, 9, that would be like all the way up here. All right, so unfortunately, we can't really make that guy look nice, but that is what that graph would look like. All right. All right. Let's go ahead and we're going to try, let's skip ahead to example D here. So, for this one, it says the trajectory of water from fountain A is represented by a function in standard form, while the trajectory of water from fountain B is represented by a table of values. Compare the vertex of each function, okay? So we need to find the vertex of these guys. Now, here's the deal. Looking at this quadratic, we can see that our A value is negative. And we learned that a negative A value means that we're going to open down like a frown, okay? And finding our vertex is going to give us our highest point, our highest trajectory of this water. Now, for fountain B, okay, if we kind of went and plotted these points, you can see that we have like -4, 10, and then we have like 2, 8 values, and then 2, 5 values. So again, we are getting this upside down quadratic, right? Down like a frown. So essentially what we're trying to do here is find the vertex, okay? So if we go ahead and take a look at A, again, to find the vertex, we need -b all over 2a, okay? So our A value is our coefficient on our x squared, so that's going to be -1. Our B value is 2, and our C value is 8. So we're going to go ahead and plug this in, and we get -2 over 2 times -1, which gives me -2 over -2, which gives me 1, okay? So this is my axis of symmetry, which is 1, and we know that the x value of my axis of symmetry gives me the x value of, or I should just say the value of my axis of symmetry gives me the x value of my vertex. So now I can go ahead and plug that into the function. So we do -1 squared plus 2 times 1 plus 8. All right. And we can go ahead and plug this in. And we get -1 squared plus 2 times 1 plus 8. And when we do that, we get a 9 out. So what this means is that this quadratic is going to reach a maximum height of 9, okay? So this kind of shows how far, the 1 shows how far it goes out, but the 9 is going to show how high it goes, okay? So for fountain A, our max value, our max height really is what I should say, is going to be 9, all right? Now for fountain B, one way to identify a vertex is, remember how around the vertex you're going to have those y values kind of repeat around it? That tells us that this is our vertex. Our vertex is -4, 10. So it would look like that, like I mentioned. So our maximum height is our y value, right? We can see that we went 4 in this direction, but 10 up. So our max height for B is going to be 10, okay? So which trajectory has a greater value? That's going to be fountain B is our answer.